I'm going to be presenting the winghead shark, also called Eusphyra blochi by its Latin name. I chose the species because it's a pretty rare species, so I was interested in learning more about it. Okay, so this is the kingdom tree for the winghead shark. It's in the Animalia, which means it has derived characteristics of the cell membrane, nucleus. It's multicellular and it's a mouth eater. These other kingdoms, like archaea, bacteria, protista, fungi, and plantae, they, for example, they don't have all of them. For example, archaea only has cell membrane. Bacteria has both cell membrane and a peptidoglycan cell wall, which is different. Protista has the nucleus, but it does not have any of the rest of derived characteristics, and so on and so forth. This is a taxonomy of the winghead shark. It's part of the domain Eukarya. Its kingdom is Animalia, as I explained before. It's in the Chordata phylum. It's in the class of Chondrichthyes. It's in the order of Carcharhiniformes, and its family is Sphaeronidae. The genus is Eusphyra, as I said before, and so the species is Eusphyra blochi. This is a phylum tree for the winghead shark. It's in the Chondrichthyes, which is seen right here, which means it has the characteristics of having vertebrae and jaws, while also being in the Animalia kingdom. So the fossils of the winghead shark, because it's a very rare species, it's hard to find them, but there are several teeth. For example, what's special about the winghead shark's fossilized teeth is that they have smooth cutting edges. They have a distinct notch on the distal side, on this side, and the distal side is enameloid, and then there's a deep nutrient groove here and here. For another one of the fossils, these are just two teeth that are in different views, and these are the formation is called calvert. These are found in the early to middle Miocene age, which is about 18 to 15 million years ago, and they were found along the Calvert Cliffs in Maryland. And as you can see, they all have the nutrient groove notches, and they have the different characteristics I discussed before. So one of the system adaptations of the winghead is that it's the only hammerhead in its genus, which is different. It has an extreme cephalofoil, which is the hammerhead part of it, which makes it look like airplane wings. Scientists aren't really sure why its cephalofoil went through evolution to get this large, but the winghead itself is one of the smaller of the hammerheads, and it reaches sizes about 1.8 meters long. It has, because of its long hammerhead, it has proportionally one of the longest nostrils among the hammerheads, which increases its chances of detecting odor molecules. This means that scientists have calculated that they're capable of sampling over 2,300 cubic centimeters of water per second for odors. This also means, because of their large surface area, that they have a better ability to detect the electric field because of the surface area of the cephalofoil. So the food web of the winghead shark, it kind of goes along with all the rest of the sharks. So here you have the zooplankton, the phytoplankton, and of course zooplankton eat phytoplankton, and then crustaceans also eat phytoplankton. And fish eat the zooplankton, as the arrows show, and then squids eat all. They eat fish, crustaceans, phytoplankton, and zooplankton. And then the bottlenose dolphins, they eat squids, fish, and crustaceans. And then both killer whales and sharks eat bottlenose dolphins. So the winghead is, it mostly inhabits this area, which is the tropical waters from the coastal areas of the Indian Ocean to northern Australia. It's a pretty limited area, unlike most sharks. And these are my citations.